On the last 2 days, we talked about rotating angles in the XY plane. And there are two ways to measure angles. The first is degrees, in which case we have 360 as a full circle, 90, 80, 180, and 270. So, where would a 35-degree angle be? In quadrant 1. So it's right here. This angle is 35 degrees, and the dial is going to become the ladder. So we're going to call this 1. Whatever it is, we don't care. It's 1. And then I can draw the wall, and then I can do all the trig I need in that triangle. What about a 150-degree angle? Where's that? That's in quadrant 2. So I rotate 150, and where do I put the wall? On the left side. Well, here's my wall, here's my ladder length 1, and I need to know what is the angle right here. How do I figure that out? Well, this angle is 150, so 180 minus 150 would be 30. So that's a 30-degree angle, and that is called a reference angle. In quadrant 1, theta is inside the triangle most of the time, right? Unless you go backwards, right? If you did negative 300, then you're going to end up with a 60-degree reference angle. So the reference angle is the angle between the ladder and the ground. The ground is always the x-axis. This will always be the ground. So the reference angle is the measure between the ladder and the ground. So in quadrant 2, we have to put the wall on the left side. Okay? And the funny thing is, if I put a 30-degree angle over here, let me draw a picture. So if that's 30 degrees, and if this is 30 degrees, then this angle would be 150. So the height of the wall, the sine of 30, should be equal to the sine of 150. Because when theta is 150, the reference angle is 30, and the walls should be the same height, right? So the sine of 30 is 0.5. What does that mean? 50% and half a ladder. It's when the ladder is length 1, it's both a distance and a ratio. Okay? Well, in quadrant 2, if I take the sine of 150, so I rotate 150, and I put my dial there, now the reference angle is 30 degrees. So the sine of 150 should be exactly the same thing as the sine of 30 because the reference angle is the same. So the sine of 150 is 0.5. So we can now take the sine of an angle bigger than 90. Originally, it had to be less than 90 because at 90 degrees, there's no triangle. And then we started this chapter and we included 90 by putting the ladder straight up and down. And now we've extended the angle to anything we want. For instance, so what about 210 degrees? What quadrant would that be in? That's in quadrant 3. Where is the wall? It's on the left side again. The wall always has to touch the ground. The wall is always vertical, and it always has to touch the ground. So what's the reference angle? (210 minus 180 is 30. Do you think I did that on purpose? I just picked 210. That was the angle I chose. 210 degrees lies in quadrant 3. Well, how far past the ground did I travel to get to 210? 30. So this little angle is 30. So the sine of 210 should be what? Should be 0.5. Okay, let's try it. The sine of 210 is, ooh. So we now have a triangle where one of the sides is negative. So this is negative 1/2. Why is it negative? We're underground. Now the wall is underground, so it's got to be negative. Okay. What about 330 degrees? Where's that going to land? Quadrant 4. What's the reference angle? 30. So the sine of 330 should be negative 0.5. Why negative? Because the wall is below the ground, so we can double check. The sine of 330 is negative 0.5. So we've now created angles that are larger than 360. We can take the sine of any angle we'd like. We now have negative side lengths. And all of this is going to fit together in a couple days to create something you've seen before. You just didn't understand what it was doing. Okay, so let's get rid of, everything's been 30 degrees so far. Let's try something else. 285. Where is that? Quadrant 4. We go past 270. What's the reference angle? Yeah, 360 minus 285. 75 degrees. So the reference angle is 75 degrees. Should it be negative 75? Well, if I rotate negative 75, don't I land in the same place? Yes, but reference angles actually create a triangle. Can a triangle have a negative angle? Well, you're unsure now. You didn't think it could have a negative side. But angles in triangles must be positive. Yeah, it just doesn't work. Now, can side lengths be negative? Yes, only if they're graphed in the xy plane. If there is no xy plane, there are no negative angles. All angles are positive unless you start here and you rotate that way. That's the only time you have negative angles. No triangle has a negative angle in it. Okay, what about 165 degrees? What quadrant does that land in? 2. That's 165. I draw the wall. What's the reference angle? 15. I need 15 more degrees to make it to 180. Okay? Negative 260. What quadrant is that in? Negative 2. So I rotate around. There's 260. Ooh, careful. This is 10, but that's not the reference angle. The reference angle is this one, which is, well, if that's 10, then the other one has to be 80. So there are lots of ways to figure this out. You could say 260 minus 180 is 80. Or you could say 10 more degrees would get me to the positive y-axis. And this is a right angle, so if that angle is 10, then this one has to be its complement, which is 80. There are a lot of ways to figure that out. Now, some of you don't like negative angles. Well, guess what? Every negative angle is exactly vertical of every corresponding positive angle. So 260 would be right here, in which case the walls line up perfectly. So you can find the positive angle and then just flip it upside down, you'll get the negative angle. So if we were doing negative 160 degrees, you could find 160 and then just flip it upside down. That's negative 160. Right? And that works in every quadrant. Every positive angle is exactly vertical of its negative counterpart. Okay? All right, what about 490 degrees? Well, I don't like 490. What am I going to do to it? Subtract 360. So 490 subtract 360. Oops. It's going to be 130, which is quadrant 2. So the reference angle would be 50. So we're going to go all the way around to there, and I need 50 more to make it. Now, if we can change positive angles, can't we change negative angles? So if I had negative 130 and I don't like it, I just add 360 to it and then graph this angle, because direction and number of rotations doesn't matter. We don't care how many rotations there are. All we care about is where you stop. The reason is the sine of 30 is 0.5. Well, what if I add a full rotation? The sine of 390. It's the same number because the reference angle didn't change. All we changed was the number of rotations, and we don't care how many rotations there are. How many different triangles are there that have a wall height of 0.5? An infinite number. An infinite number of positive angles and negative angles. And we don't care anything about the rotation except where it stops. All right, now radians. Radians seem difficult, but if you think of them in terms of fractions, they're not so bad. So the top half is pi radians, 1 pi. The bottom half is also 1 pi, so a full rotation would be 2 pi, which means the 90-degree mark is half of a pi. It's half of the top. And the 270 mark is 1/2 more than 1. The top half is 1 pi, the bottom half is 1 pi. If we go to 270, we do a full top, half the bottom. We end up with 1.5 pi, or 3 pi over 2. So if you can change these fractions into other fractions, radians are a piece of cake. What if we decide to cut our pizzas into 6 pieces? So that's the plan, 6 pieces. How much of a rotation is that if our pies are cut into sixths? That would be 3 over 6. How much would that be? 6 over 6, a full pie. How much would this be? 9 over 6. How much would that be? 12 over 6. Okay? All right, what if we did 14ths? What would that be? 7 over 14. And this? 14 over 14. And this? 21 over 14. And that? 28 over 14. Now, even denominators are easier, but you can do the same thing with odd denominators. So let's say ninths. So what would that be in ninths? 9 over 9, so half of that would be 4.5 over 9. So this would be 9 and 4.5, 13.5 over 9. And this one, 18 over 9. And you can keep going, right? 27, 36, we can keep going. Okay? So if I gave you the angle 3 pi over 4, is that going to land in the top half or the bottom half? The 3/4 of pi. The top half is a full pi. The bottom half is also a full pi. Did I complete a full pi? No, we're not talking about number of rotations here. We're talking about the number of pi. If you have 3/4 of a pizza, and the top half is a pizza, we didn't finish the top half. So this would be 2 over 4, and this would be 4 over 4. Where does 3 over 4 fit? Quadrant 2. So you have to think of it in terms of pies, not rotations anymore. A rotation is actually 2. So we talk about top half and bottom half. Now, what's the reference angle? Well, the angle given is 3 pi over 4, and the reference angle needs to get us to 4 over 4. So it's just 1/4. Radians end up being a lot easier. You don't even need a calculator. Right? You can do this subtraction in your head. The top is 4/4. The angle given was only 3/4. How many more fourths do I need to complete the top? 1. Okay, what about 6 pi over 5? Is that going to be in the top half or the bottom half? Why the bottom? It's bigger than 1. So this would be 5 over 5, and this would be 10 over 5. So I'm going to rotate to 5 over 5 and 1/5 more. So the reference angle is just pi over 5, because I went 1/5 more than 5 over 5. So I have 6 pieces of a pizza, and the pizza contains 5 pieces, so I have 1 piece left over, 1/5 left over. Okay, what about 13 pi over 9? So the top half would be 9 over 9, and a full rotation would be 18 over 9. Am I closer to 9 or am I closer to 18? How close am I to 9? 4/9 away. How close am I to 18? 5/9, which puts me in just barely in quadrant 3. Okay, so what's my reference angle? Well, I already figured it out. How far past 9/9 did I go? 4/9. When you figure out which side you're closer to, that's the reference angle. So this piece was 9 over 9, and I need 4 more ninths to reach 13/9. So, well, it's 4 pi over 9. That is the reference angle. I'm 4/9 beyond 9/9. What's your question? So this would be 4.5/9. All right. What about 23 pi over 11? This one's kind of tricky. The top half equals, yeah, so this is 11/11. This is 22/11. So we go all the way around and 1/11 more, so the reference angle would be pi over 11. 1 pi over 11. Okay, what about this? 16 pi over 9. Fourth quadrant. So how much is this? That's 9 over 9. And that? 18 over 9. And I'm closer to 18, which puts me in quadrant 4. How much more do I need to finish the circle? 2/9. So 2 pi over 9 is the reference angle. Right. Okay, what about negative 5 pi over 3? So we're going to go backwards. How far to there? Negative 3 over 3. How far to there? Negative 6 over 3. So I'm closer to negative 6, which puts me in quadrant 1. How big is that going to be? But reference angles are always positive. Pi thirds. Pi over 3. Yep. Well, the nice thing about the worksheet is they've given you the angles and where they land. All you have to do is find the reference angle. So let's do one more. 23 pi over 18. 36. So the top half would be 18 over 18. The bottom half would be 36 over 18. So 23 pi over 18, is it closer to 18 or is it closer to 36? How close is it to 18? 5. So we go around the top half and 5 more. What's the reference angle? 5/18 pi. 5 pi over 18. Okay. All right. The rest of your worksheet is review. That gets you from 1 to 10. Take a look at number 11. Do those two angles land in exactly the same place? How do you tell? You just keep subtracting 360. If you hit it, if you hit the other angle, it does. If you miss it, it doesn't. Number 12. What are we going to add to 17 pi over 36? Nope, 36 over 36 is only the top half of the circle. So you need to add 72 over 36. If you add it once, you're still going to be way too small. So you add it again. If it hits it, the answer is yes. If it misses, the answer is no. All right, 13 through 16. Find a coterminal angle between 0 and 36. So there are an infinite number of answers. The answer it wants is the one that's bigger than 0 and smaller than 360. So for number 14, what are you going to do? Add 360, but you're going to have to add again because that answer is going to be too small. Okay, number 17, find a coterminal angle between 0 and 2 pi. So number 17, your pi's are cut into thirds. What is a full circle if the top half is cut into thirds? 6. So am I going to add 6 over 3 or subtract 6 over 3? Why subtract? The answer that's given, 11 thirds, is way bigger than 2. Yes. So 11 over 3 minus 6 over 3 is 5 pi over 3. Is 5 pi over 3 small enough? Is 5 over 3 less than 2? It's less than 6 thirds. So yes, it has to be less than 6 thirds. What are you going to do to number 18? You're going to add 36/18. Is that going to be enough? Yes. What's your question? The fraction you get for number 17 through 20, the answer they want is a fraction between that has a decimal between 0 and 2. So if we look right now at 11 thirds, that's 3.6. So do I want to subtract or do I want to add? I'm going to subtract. So I'm going to subtract 6 thirds. 6 thirds is 2 pi written in thirds. A full rotation is 2 pi, also known as 6 over 3. Why did I pick 6 over 3? Because the denominator is 3. Okay, 21. Find a positive and a negative coterminal angle. Add what? 8/4. I'm going to add 8/4 because that's a full rotation in fourths. And then I'm going to subtract 8/4. Okay. Get to work. Good luck.